Hi, I am Akshay Ramesh from Dublin City University, and our paper title is Investigating Lower Source Machine Translation for English to Tamil. The co-authors for this paper are Venkatesh BP from Dublin City University, Rijwanul Haq from Adapt Center, and also Andy V from Adapt Center. To give you an outline of the paper, so in this work, we investigate the performance of phrase-based SMT and neural MT on a rarely tested lower source language pair, English to Tamil, and we take a specialized data domain software localization into consideration. In particular, we produce rankings of our MT systems via a social media platform based human evaluation scheme and demonstrate our findings in the low source domain specific text translation task. In an attempt to test MT on low resource scenarios, we chose English and an Indian language, Tamil. English and Tamil are Germanic and Dravidian languages, respectively. So, the languages we selected for investigation are from different language families and morphologically divergent to each other. English is a less inflected language, whereas Tamil is a morphologically rich and highly inflected language. Our investigation is from a less inflected language to a highly inflected language. With this, we compare the translation in PBSMT and NMT with a translation pair involving two morphologically divergent languages. A quick overview of the corpus. So we carried out experiments using two different setups. The first setup, which we call the mixed setup. Here, the empty systems were built on a training set compiled from all data domains listed as in the table. And in the second setup, we call it IT setup. And here, we built our training set compiled only from software localization data from Opus, that is Genome, KDE4, and Ubuntu. The development and test set sentences were randomly drawn from these localization corpora. Coming to the automatic evaluation results, we present the comparative performance of the PBSMT and NMT systems in terms of widely used automatic evaluation metric, BLEU. The BLEU scores reported in these sections above are very low. We looked at the translations of the tested sentences by the empty systems and compared them with the reference translations. We found that despite being good in quality, in many cases the translations were penalized heavily by the BLEU metric as a result of many n-gram mismatches with the corresponding reference translations. This happened mainly due to the nature of target sentence, that is the nature of Tamil in question, since Tamil is a free word order language. This is indeed responsible for the increase in non-overlapping n-gram counts. We also found that translations contain lexical variation of Tamil words of the reference translation, again resulting in the increase of non-overlapping n-gram counts. The empty systems were built exclusively on in-domain training data, and in the mixed setup, the training data is composed of a variety of domains, that is religious, IT, political news. In a nutshell, when we compare the PBSMT and NMT system, we see that PBSMT is always the leading system across the training data setups. Now coming to the MT system ranking, we further assess the quality of our MT systems, that is the English to Tamil, PBSMT and an MT system, via a manual evaluation scheme. For this, we select our PBSMT and NMT systems from the mixed and IT setups. Additionally, we consider Google Translate in this ranking task in order to compare it with PBSMT and NMT. In order to conduct this evaluation, we developed a web page that was made available online and accessible to the evaluators who ranked the MT systems according to their translation quality. This website was shared through LinkedIn and Facebook. We randomly sampled a set of 100 source sentences from the test set based on the sentence length category. So we obtained 33, 33 and 34 sentences from each of the short, medium and long sentence length categories. Now we will obtain the corresponding translations for each of this 100 sentences from each of the engines. The web page displays 10 sentences together with the translations by the MT systems, which are taken randomly from the sentence length sets with a minimum of 3 sentences from each set. The evaluators, who are native speakers of Tamil with good knowledge of English, were instructed to rank the MT systems as per the quality of translations from best to worst. It was also possible that evaluators could provide the same rank to more than one translation. We see from the results that NMT is found to be the winner for first sentence length set, that is the short sentence length set, followed by GT and PBNMT. As for the other sentence length categories are concerned, GT becomes the winner, followed by PBSMT and NMT. So short sentences are translated better by NMT engine, whereas GT translates the medium and longer sentences better. If we recall the automatic evaluation results we presented, so the scores of our English to Tamil MT systems, we had 9.56 blue points for PBSMT at the first spot, and then we had NMT with 4.35 blue points at the second spot. Now we additionally computed the blue scores for the translation produced by GT, which is 4.37 blue points. So we see that PBSMT is the best choice, and GT and NMT both are comparable if the MT systems are ranked according to the automatic evaluation scores. Therefore, the automatic evaluation scores result in a contradiction with the human evaluation results shown. So, in order to validate our human ranking results, we computed the inter-annotator agreement using Fleece Kappa for the 3 ranking positions, first, second, and third. And the results are 74.1, 58.4, and 67.3 respectively for the mixed setup, and 75.3, 55.4, and 70.1 respectively for the IT setup. A kappa coefficient between 0.6 to 0.8 represents a substantial agreement. In this sense, there is a substantial agreement among the evaluators when they select the positions for the MT systems. So to wrap up, the use of in-domain data only at training has a positive impact on translation from a less inflected language to a highly inflected language. Then we looked at the translations produced by our MT systems and found that in many cases the blue scores underestimate the translation quality, mainly due to the relatively free word order in Tamil. From our human ranking task, we found that the sentence length could be a crucial factor for the performance of the NMT systems in low resource scenarios. That is, NMT turns out to be the best performing for very short sentences. This finding indeed does not correlate with the findings of our automatic evaluation process, where PBSMT is found to be the best performing and GT and NMT are comparable. This finding could be of interest to translation service providers who use MT in their production for low resource languages and may exploit the MT models based on the length of the source sentences to be translated. We believe that the findings of this work provide significant contributions to this line of MT research. In future, we intend to consider more languages from different language families. We also plan to include string-based MT evaluation metrics such as CHRF in our investigation, which has shown better actual improvement of the NMT engine performance. Thank you.